Part 6, doing partial fractions first before proceeding to binomial expansions. There's only one example in this video, which is this one. We're going to expand our terms up to the x squared term, the quadratic term. There are further terms, but we're not going to do those. And there's no brackets or anything to expand. It's actually a binomial expansion, even though it doesn't look like one at the moment. So we'll start off with some partial fractions. So we need a fully factorized denominator, partial fractions, work out a and b, and we've got these. You need to watch my other videos on partial fractions if this part doesn't make any sense, but I've left out the working out. You can do that yourselves. And if we rewrite our fractions in a form where we can do binomial expansions, and all I've done here is so let's say if you assume there's some brackets around that 2 minus x denominator, so that would be to the power of 1. If I bring this out, I will get 2 minus x. That power of 1 becomes a minus 1, which is basically this. Now, to do the expansion, it's going to be for the highlighted parts in yellow here, and you need a 1 plus here and here, because we have negative indices. So to use the formula for the binomial expansion, that's got to be a 1 plus here. This one's not, so some factorization is required first. I'll go through this in more detail in a minute. So now we've got these terms, and this is the bit we're going to expand here, and this is the bit we're going to expand here. Now you might think, what happened to the coefficient there? There was a minus 2 there. That minus 2 is multiplying with the half here, so you got minus 1, so there's like a minus 1 there. We do the expansions. Again, I've skipped the steps in between. Simplify the terms, collecting like terms and so on. And that answers this question. Expand up to x squared. What terms do you get? We've done that. And here are the terms. But for what value of x is the expansion valid? Now we did 2 separate expansions, so the magnitude of the x term here has to be less than 1, and the magnitude of our x term here, the minus half x, has to be less than 1. So we've got this, and we have to look for the set of values of x which will satisfy both inequalities. If I multiply by 2, so for this, x has to be between minus 1 and plus 1, but not including the minus 1 and the plus 1, so we're looking at the interval here. And for this, x has to be between minus 2 and plus 2, but not including the minus 2 and the 2, and the set of values of x which satisfy both of these inequalities. So the overlap here is in this region. So we can say that the whole expansion is valid for this condition, for x. For practice, try these questions.